Good afternoon. My name is George Kimes. I have the pleasure of serving as the president of the board of directors for Brain Futures. I also want to thank you for attending and hope that you have a great 2 days here with us. Also want to add a thanks to our partners, sponsors, and exhibitors. Without them, it would be very difficult to do this. In addition to the focus on new technologies that you see in the expos and on the screen, Brain Futures is raising awareness of the science surrounding simple things we can all do to keep our brains performing well from childhood to our twilight years. The strategies you'll hear about in the next talk are not particularly surprising, but although they're a routine part of the conversations for other major health conditions, they're rarely discussed in mental health treatment. We're fortunate to have with us today one of the foremost experts on the brain-fitness connection. Psychiatrist and Harvard professor, Dr. John Ratey, has embarked on a worldwide mission to re-engineer schools, the workplace, and individual lifestyle practices by incorporating exercise to optimize performance and mental health. He has established a nonprofit to promote exercise and the treatment of mental health and is the author of many books on mental health and the brain. Most recently, Go Wild and Spark, the revolutionary science of exercise in the brain. Please join me in welcoming Dr. John Ratey.
Thank you. We sort of feel like we're going from the sublime to the ridiculous, having me here. But anyway, do you all need a brain break, a little brain break? You want to do that? So why don't you all stand up a little bit, stand up, and I'll do my patented, lead you in the Hindu squat. Now, I was in Mumbai with 500 Hindus in the room, and we did this, and I asked if anyone had ever heard of it. No one had. So I don't know where the name comes from, but this is what you do. Put your hands out in front of you like this, pull them in real tight, and then bend down and touch the floor, if you can. Let's do it again. Pull it in and bend down and touch the floor. Pull it in again like that, yep, and bend down and touch the floor. We'll do a couple more. Pull it in, touch the floor. I usually have people scream, but that's not good. Touch the floor. Okay, okay. Enough. Now what we did, we moved our major muscle groups, but we also turned our brains a little bit on, a little bit more on, especially the attention system, which is part of what I've studied for many years. So what does exercise really do? Exercise helps, and play helps to regulate our brains, helps to regulate our emotions and optimize cognitive function, as well as preserve cognitive function. Now, this all started many, many years ago, but there was a big study in the end of the 80s, beginning of the 90s, an international study looking at what were the lifestyle issues that prevented people from going into cognitive decline and Alzheimer's disease. And they came up with three major issues. One was optimal weight. Two was continuous learning. And three was exercise. We had known about the first two a bit. Exercise, even when they factored out the positive cardiovascular elements of lowering blood pressure, lowering stroke risk, improving circulation, all that, exercise was still, why was it there? Why was it so powerful? So one of the authors, Carl Cottman from the UC Irvine, went back to his lab in the early 90s, and he wanted to investigate it. So he got a bunch of mice, and he did what I call the mice SATs on them. and then taught these mice to run in these running wheels. And it was surprising that the mice liked to run. They ran, on average, 4 kilometers a night, which is a long way for a mouse with little feet, little legs. And then they retested the mice after 7 to 10 days. Their SAT scores went up 20%. This was a big deal. So he used mice and had a bunch of controls that didn't have the running wheels. Their SAT scores didn't improve. So then he looked at their brains, and what he found out was the cortices, or the top part of their brains, were thicker than the control mice. Then he weighed the brains, and they were heavier. And then he looked inside the brains, and one area of the brain that's key and so important for all kinds of things, but especially memory and learning, the hippocampus, it was bigger than the control mice. So this started the revolution. He also measured a new found growth factor that we discovered some 15 years before that, called BDNF, brain-derived neurotropic factor. And BDNF was really hot then, and it's really, really hot now, because we know so much about it, because it's really, truly brain fertilizer. And I learned about it after reading his study in Nature, and I was talking about exercise and how valuable it was, and I called this BDNF Miracle Grow for the Brain, because it really is something that's necessary for our brain cells to remain young and perky and resilient and resistant to stress. So this led me on a lifelong journey to understand what's going on. Why do we exercise? What is happening? And I went back to try to understand hunter-gatherers, because I realized that our genes that we have today evolved over those 6 to 8 million years that we were hunter-gatherers, and so did our brains. And in fact, it's only been in the last 10,000 years that we haven't been moving like our hunter-gatherers did. It's said that they moved on average 10 to 14 miles a day. And we, even with our Fitbit, it's not nearly 10 to 14 miles a day, but it gets there. So the hunter-gatherers sort of led me to try to understand why we need to move. What does movement do for us? So when we look at the brain, the front part of the brain, our frontal cortex, the front part in front of the red motor cortex, grew during our hunter-gatherer period. We added on more parts of the brain, more brain cells during these 8 million years or so. And we added them on to help us be better movers, to help us be predictors, to help us sequence movements, to evaluate, to assess, to remember, to evaluate consequences of our movement, all the things that we do as humans. And then, as we got bigger tribes and we got language, we use those same motor-derived nerve cells to think with. And one of my favorite quotes is by Rudolph Linnaeus, who said, "That which we call thinking is really the evolutionary internalization of movement." So our moving brain activates our thinking brain cells. So this paper came out in the mid-90s, and since then, it's been a revolution. As you can see here, and this represents the number of papers that have been published in the literature on movement, exercise, play, and the brain. It's just been a hockey stick, if you're Canadian, kind of thing, that we have a huge group of papers coming out all the time. I was interested in this really before his paper came out. I was always interested in movement and exercise and affecting my patients because I work with ADD patients, and movement is a nice treatment for ADD, which we'll get to. But before 1995, 94, there were about 10 to 20 new papers a month in the literature. After that, after his paper, there was this tsunami of papers, and such that every Saturday morning I get sent from the Library of Medicine, National Library of Medicine, more than 100 different abstracts had been published that week on exercise and its effect on the brain. So it's a big deal. People are really interested in it. And interested in it in major way, and a lot of the studies were looking at, okay, how do we prevent cognitive decline in Alzheimer's disease? So the Mayo Clinics did a review, and the Department of Neurology did a review in 2011 of over 1,600 papers that had been written in the past 20 years or so on exercise and its effect on cognition, its effect on the brain, keeping it intact. And their finding was that they were all positive, that exercise had this very profoundly positive effect on preserving the brain's function as well as raising the test scores. And one of the studies, one of the pioneers in this area was Art Kramer from the University of Illinois, who really followed this exercise and keeping away Alzheimer's disease, keeping away cognitive decline. And he did this study and published it in 2006, but it's a really colorful study. I love the colors here. So basically what he did is he got a bunch of 67-year-olds who were sedentary, 100 of them, had 50 of them start to exercise. Another 50, they came in for stretch classes 3 times a week. The exercisers got on a treadmill 3 times a week for 6 months, and they exercised during the days that they were exercising about 30 to 45 minutes, getting their heart rates up to about 70, 75% of their maximum. So they were sweating. Well, what they found, they did the elderly SATs before, and then after the 6 months, their SAT scores went up 11% compared to the control group. But then he took these fancy, the MRIs, and looked and compared them pre and post. So this is a compilation of that, and you see the blue and the yellow areas there. Looking at it, those were areas of brain growth, that the brain actually grew in humans over that 6-month period when they began to exercise. Like Norman and mentioned, we've just been deluged with all kinds of information about Alzheimer's disease and trying to prevent it and understand it. And the big thing is decreasing inflammation in the brain, along with many other activities, but to keep the inflammation down. And that's really quite important. And one of the pioneers now at the Mass General, Rudy Tanzi, came up with these kinds of ideas about keeping our brains healthy. But as Norman mentioned, Dale Bredesen and Rudy Tanzi, the first thing they talk about in terms of lifestyle changes is exercise. The very first thing. That's always at the top of the list. Then diet, then sleep, then social interactions, which is huge. And it gets bigger as we learn more. Now, many of you feel that your chance to exercise is past. Okay, you know, it's by you. You should have been doing it earlier, which is true. But just to show you that our bodies respond to demands, a lot of you from Maryland, right? And the woman on your left there is Ernestine Shepard from Baltimore. And she's been on the cover of the Washington Post Sunday magazine. That's where that's from. But anyway, Ernestine was 56, and she had always been obese. And sat there one day and said, I'm going to get fit. So she started to run. And she started to run more. And then she started to go to the gym and lift weights. There she is at the age of 74, looking pretty good. Even more impressive is, on my right, is Mr. Singh. Mr. Singh was 80 and had never exercised. His wife died. At the age of 81, his son died. He went to the doctor because he was depressed. And the doctor said, start running. So he did. There he is at the age of 100, finishing the Toronto Marathon. He retired on ESPN last year, 2 years ago now, at the age of 101, finishing the Hong Kong Marathon. So the point being is it's never too late. Never too late. Now, something about the information that we've been given. There's a doctor saying the high carb diet I put you on 20 years ago gave you diabetes, high blood pressure, and heart disease. Oops. It also led to early cognitive decline and Alzheimer's disease. So our diets are really important, and sugar is one of these toxic things that we take in, and I'm just throwing this in here because I think it's so important. Sugar and starches and all the things that get broken down into more and more glucose are toxic to our cells and to our brains. And inflammation is now all over the news. This was just this week about chronic inflammation and cardiac disease. So we really want to pay attention in our lives from here on to inflammation and what we can do. Now, being a psychiatrist, one of the reasons why I was interested in exercise is not just for treatment of my ADD patients, but also depressed patients, because we sort of knew a little bit that exercise was a good treatment for depression. Well, we knew a lot, actually, about it. Hippocrates wrote in the first medical textbook, 300 years BC, that his treatment for depression was to send his patients for a walk. And if they came back and they weren't better, he sent them again for another walk. Keep moving. Well, it's only been now 4 or 5 years that the American Psychiatric Association has finally succumbed to the evidence and listed exercise as a possible treatment for mild to moderate depressions. And that really comes to us mainly started in a very scientific way from Duke University Medical School and James Blumenthal and his group there, who began to look at patients who were starting to exercise, sedentary folks who had a heart problem, and they were sent to the cardiac rehab specialists, and they were on their treadmills, and he noticed that they were better. That not only that they were preventing the heart disease from getting worse, but they were less depressed. They were moving from type A to type B. They weren't as aggressive. They weren't as anxious. They were kinder. All these things. So that he began reporting on this in the 80s and in the 90s, and finally at the end of the 90s he published this study that looked at 100 depressed patients who came into Duke over a 4-year period, divided them into 3 groups. The first group, and they were all sedentary. First group, he began on an exercise regimen 4 times a week for 30 minutes on a treadmill. Another group, he gave increasing doses of Zoloft, one of our antidepressants. A third group, he did both, and then followed them. It was a 4-month study, so they followed them in, week to week. And he found at the end of 4 weeks, their depressive scores all dropped to about the same level. Well, this was great for him, but really bad for the industry who was selling antidepressants. So there was a lot of, oh, you didn't have a placebo group. So he then the next decade got a placebo group involved in a much bigger study, 250 patients who were moderately depressed, doing the same kind of thing. One group he had exercising, another had exercising and Zoloft, another group just Zoloft and a placebo. And lo and behold, all the intervention groups got better, had better remission of their depressive symptoms. So finally this took some people to really say, okay, exercise really has a place in treating our mood disorders. And this is a study that came out looking at very, very depressed patients with bipolar II depression, very depressed, in their chair, can't move. Got them up, put them on a treadmill with an assistant to be there and encourage them, and then measured their variety of feelings, their depression, their tension, their anger, their distress and hopelessness. All of them improved when they got moving and persisted for a while, but then reverted back to their very, very depressed state. So, and what we're doing today is people are drilling down to find out what happens. Why does exercise have such a profound effect? And one of the key players is looking for what makes BDNF, what makes us have more BDNF. Some people say, well, because we're firing so many brain cells when we move, we make more BDNF because of that. There's other factors involved, some from the periphery, some from the brain itself, to increase our levels of BDNF. Because in that initial study with the mice, he found that their BDNF levels were 2 to 3 times what it had been at the beginning. So we knew that BDNF was raised in all the studies that have come out subsequently, that exercise increases BDNF like nothing else, like no meds, no drugs, nothing else that we can do, although that was a big problem for the pharmaceutical industry. And also now we're learning about why exercise is so great for reducing stress. Many, many reasons for that, but one of them is we become more resilient to stress. And I call exercise stress inoculation, because you do stress yourself with exercise, but then you have recovery, and then you build up all this resistance to stress. And one of the studies that came out just a couple years ago by Elizabeth Gould and her colleagues at Princeton showed that we were making new brain cells every day, and that was one of the findings that came out in 1999. We make new brain cells every day, and exercise increases the number of new brain cells that we make. We turn on our stem cells with exercise, and we produce enough BDNF or fertilizer to sustain them, much more than in any other human activity. Well, she targeted what kind of new brain cells we're making. And she found that a lot of the new brain cells that we made were GABA-containing nerve cells. And GABA is the major brake in the brain. And in the hippocampus, it works to put the brakes on stress, cortisol. One of the things that we've learned in the past 15 years is that the hippocampus is very much involved with stress regulation. And if we have more GABA or inhibitor in the hippocampus, we're going to be more resistant to threats from the environment or stress from inside our head. And so we're improving the brain's resistance to anxiety and stress. Now, it says this is a typical hyperactive child. Funny, he was here just a second ago. I've done a lot of work in attention deficit disorder. So then I got this dog, a Jack Russell, and one of the things I learned very quickly is that Jack Russells as a breed all have attention deficit disorder. So I took him into the vet. The vet said, put him on Ritalin now. Rather than doing that, I just devised an exercise program for him. So in the morning, we'd go in the backyard. I had 3 tennis balls. There was a hill in our backyard. I'd throw one tennis ball up the hill. He'd go charging up after it and come back down, show me that he got it. It was a terrier. He's got it. Wasn't going to drop it, but I had 2 others. So I threw the other one up, and he had to drop it and go up after it and come back down. And this went on for about 15 minutes every morning. And this is what happened. He was able to do his homework. And when people write me after I lecture, all they want is slides of Jack. I'm telling you, it's amazing. And there are times when we don't get outside, and then he reverts to his old ADD self, sort of playing around with things and causing trouble. And this can lead to that. It's really not Jack, okay? Somebody sent that to me. So anyway, but we know, and many studies now have been out showing that exercise is a great co-treatment for our kids with ADD, learning disabilities, with autism, and centers are really getting attuned to that business. So one of the things that happens, one of the facts we know, is that when we move around, our brain gets turned on. This is now a famous slide looking at the effect of 20 minutes of walking. On your left is a QEEG of 20 students who came in and sat down. They did a QEEG. Then they went for a 20-minute walk, came back and did the QEEG again. You see more colors, more activity of the brain. The cortex is turned on. And really, when we look at all the studies, the big part of the brain that's really turned on, really activated, is the prefrontal cortex, the part of the brain that's there in purple. And in the ADHD world, the frontal cortex is really key, because this is where we have our executive function, where we have working memory, where we sort, where we decide, where we choose, where we predict, and also where we put the brakes on our impulses coming up from below. So we want to activate that, and exercise is one way of doing that. So we know that exercise improves cognition. It improves our ability to think and remember and sort and keep growing. And then I became very much enamored and heard about this school in Naperville, Illinois in 2003. It's my first chapter in my book, Spark, and it really changed my life. Because here was a school of 19,000 kids in their school district that had evolved a PE program over 20-some years. And the reason they came to my awareness is they were on Frontline, and they were talking to the PE teacher who was responsible for changing their PE program, because they had PE, physical education, every day. And they had decided to change their course and started focusing on fitness. Well, the reason why they were on TV is because we were beginning to worry about the obesity crisis. And of these 19,000 kids, 3% of them were overweight. The percentage in the US at that time was 33%. Well, that was great and great for health, but a couple years before that, 99% of those kids took the TIMSS test, the International Science and Math test, which every country takes every 3 years. We took it 2 years ago, and we came in 19th and 20th in science and math. We used to come in 10th and 11th or so. Well, anyway, they lobbied to take it as a country. You could do that. A school district could take it as a country. So they took it as a country, and they came in #1 in the world in science and #6 in math. So not only were they among the fittest kids in the US and maybe in the world, they were among the smartest. So that's what led to my work in trying to promote and re-energize the schools by getting them to move again. Well, we already knew that, I mean, we had data to show that the fitter you were, the better students you were, the better test takers you were. And believe me, the teachers, that's all they're pressured to do is improve test scores. So in California, they test kids, 1 million kids a year in grades 5, 7, and 9 on something called a Fitnessgram, which is a measure of your fitness, your overall fitness. And what they showed and show every year, as the fitter the kids are, the higher their test scores on math and English. It's a straight line graph. In other words, the more fitness measures that they have or meet, the better they do on tests. 10 minutes, okay. Then we have data that comes in from all over the world, but this one from Sweden, to me, was the proof. Maria Aberg, who's a renowned epidemiologist, looked at 1.2 million boys who had been tested at the age of 15 when they entered high school, and retested at the age of 18 when they entered the military service. And they tested them looking at their cognitive ability, performance on tests, something like an IQ, and also measured a variety of physical abilities, including their aerobic scores, how much their endurance was, how their heart rate, all that kind of measure. And they were retested again at 18. And she found that if you improved your aerobic function, your test scores went up during high school. And this held for brothers for 650 sets of identical twins. So if one of the twins improved their aerobic function, they were liable to have their test scores improve cognitively. They followed these kids after the military, and they found that those kids that improved during high school, that got fitter, had more academic achievements, more degrees, and later on, a higher socioeconomic standing than those that didn't. So it became a rage in Sweden for a while, but as always, it drops off. People forget about it. Now, so physical activity, moving, playing, getting ourselves going, activates our brain systems, what I call brain systems, our attention system, our memory system, our motivational system. All the systems of the brain get turned on, as well as the microenvironment where our cells live, our 100 billion nerve cells. We enrich that microenvironment with this BDNF, with all kinds of other growth factors. As well, we have this business of having more new brain cells being made. So in every way, exercise promotes our ability to learn and remember. It helps control our impulses, improves behavior, improves motivation, decreases sort of a negative stance, and improves the feeling of self-esteem. These are facts from many studies, not just thrown together a bunch of items. And also, exercise helps us do what is necessary to learn, because we gave 3 Nobel Prizes to people in 1990 to show that the way we learn anything is for our brain cells to grow. If they don't grow, we don't learn anything. So we need all the growth happening, because that's the way we begin to learn. We change the synapses, we may make more receptors, we make more neurotransmitter, toughen up those synaptic connections. As well, we have many studies showing that exercise helps our brains, especially in their hippocampus, grow. This is a study that out of Columbia Neurology that looked at a bunch of New Yorkers around the age of 30 who were sedentary. They did a bunch of scans, then had them come in for 3 days a week for 3 months, rescanned them, and saw that this part of the brain, the hippocampus, grew about 30%, this one particular area. So it became really exciting stuff. This was on the cover of Newsweek and so forth and so on. But it's something that, you know, there's no one paying Madison Avenue to advertise this. And so it gets forgotten. It gets forgotten. And that's what happens. In kids, another study came out recently looking at children at the age of 10 who came in and they were tested to see whether they fit or non-fit. They were fit if they could run 400 meters, non-fit if you couldn't. Then they looked at their brains and looked at their hippocampi or hippocampuses and saw that the fit kids already had bigger hippocampuses than the non-fit kids. So again, sort of a way of looking at how exercise and activity really helps our brain grow. So what happens? Why? What is going on? Well, when we exercise, we move all those nerve cells. We have them clicking away. Many parts of our brain are activated when we move, and we release a lot of neurotransmitters. And we in psychiatry have been addicted to norepinephrine, dopamine, and serotonin. And we know that they're increased almost immediately when we move. For instance, standing here and talking rather than sitting, my brain is probably 7 to 10% more active. And I probably have 7 to 10% more norepinephrine and dopamine going for me. And when I move, like my ADD keeps me moving, you know, it even adds to that. So what happens? So that these are the targets, looking at our emotional life, motivation, as well as our ability to cognate. Now, BDNF, miracle grow for the brain, is increased all the time when we're moving. So when we exercise, running, playing, and exercising, but we also use BDNF to battle cortisol. It's a cage fight to the death. But we also increase our concentration of norepinephrine, of dopamine, and of serotonin, which we know and love in psychiatry so much. But we also increase these neurohormones, the endorphins and the endocannabinoids. And we're learning, and those of us in Boston really were focused on the endorphins and the marathoners, because everybody wanted to know why could the marathoners get into this nirvana-like state? Well, the reason we focused on endorphins is we could measure it back then. We identified it. It wasn't, we had a hammer, so there was a nail. So we could measure the endorphins, and they were raised in people who were running 26 miles, and a lot of them felt no pain, because that's what endorphins are, and endogenous morphine is. It blocks the pain receptors. Also, the endocannabinoids are recent players that we're much more aware of, especially as we get into the marijuana business, because cannabis is, we make our own pot in our bodies, the endocannabinoids. We have a lot of them. We have a lot of receptors in our body and our brain. And so when we're moving, we increase the concentration of these neurohormones that help to make us feel good, help prevent us from giving up because we're in pain too much, and in general feel better. Now, one of the things that I've spent a lot of time talking about and looking at is what in the body gets up to the brain to help I mean, we usually think of top-down, the brain influencing the body, but we also are learning that the body has an effect on the brain. We're learning about stuff that's released from the body that has a direct effect on memory, learning, and our mood. as well as on panic disorder. And then we make a lot more oxytocin when we exercise. That's one of the reasons why people that exercise together bond together a little better. The oxytocin is up in both parties, and why one of the recommendations is that we always give is, how do I get exercising and stay with it, is join a group, because you get that social involvement and you feel like you have to show up. So a Zumba class or a running club or a biking club really has a lot to say for it. And then we worry about addictions. This is amazing today, huh? This is not unusual. Everybody has a cell phone. Everybody's so addicted to it. This city in China, Chongqing, I'm not pronouncing it right, has divided sidewalks down the middle. If you're on your cell phone, you're on one side. If you're not, you can walk free. There have been so many accidents, and you get fined if you're on the wrong side of the street. And one of the things that we learned is that we get addicted easily, and especially ADD folks. We get addicted to various things very easily. We're more prone to it. Twice as likely that we're going to have a substance abuse problem than normals. So this says Game Boy, a memoir of addiction by Ronald Markowitz. But and you all know Michael Phelps' story, how basically he was self-medicating with his exercise regimen. He had been diagnosed at the age of 9 with ADD, was put on Ritalin, then began swimming. 3 years later, stopped the Ritalin, swimming 3 to 4 hours a day, and did really, really well until he stopped training. And then he'd get in trouble with drugs and problems, and until he got back playing. Well, Jack also... Jack is also prone to addictions. So when I go away, I make sure that the dog sitter knows to exercise the boy every day, or else there's going to be trouble. And I came home this one Sunday night, and look what happened. So with that, I thank you, and I'll be around for a little bit. Thank you.